number 6 says 3 points on a grid form a triangle with sides of length A, B and C as shown in the example. Right, a triangle is said to be right angled if the following test is true, where A is the length of the longest side. Right, so yeah, A squared equals B squared plus C squared, right, so just Pythagoras. Well, yeah, right, right, it just tells us what A squared means. Right, you can calculate A squared, B squared, C squared by using the coordinates of the endpoints of each line. For example, B squared is calculated as follows. Right, so the endpoints P1 and P2 have the coordinates, well, 3, 2 and 6, 6, which yeah, I guess we can see here. Right, the value B2 is given by the formula, so we take, I mean, basically what the difference in the x values, right, the difference in the y values, we square them. Yeah, I mean, obviously this is just sort of, I mean, yeah, this is just doing Pythagoras here, right, the sort of x difference, the y difference, and then, yeah, calculating this triangle. Right, so a function, right, what is right angle, will take 3 sets of integers as parameters representing the coordinates of 3 endpoints that form a triangle, and return true if the endpoints form a right angle triangle, otherwise return false. Right, in pseudocode, the caret operator represents an exponent, which is the number of times a value is multiplied by itself. For example, the value, value squared is written as, value, right, then the caret 2. Right, so we just want to complete this pseudocode, so I'm just going to copy this. Yeah, let's just copy this function header, or function signature. Right, and yeah, let's just paste it in here. So what it what it told us then was that we can calculate the length of ABC by just taking the difference between these. Right, okay, all right. So this is a little bit tricky because what we need to think, and yeah, maybe let's go back here to the example. If we have a right angled triangle, I mean, let's say this one. Now, let's say that this is kind of side 1, or, well, I mean, not side, but let's say this is kind of angle 1. Right, this is going to be angle 2. I mean, let's say, well, this is kind of, yeah, I guess not really angle, right, just point. Yeah, so point 1, point 2, point 3. And then what we can say then is that, well, the length of B, right, is therefore going to be x1, yeah, sort of minus, x2. Right, C is obviously going to be x2 and minus x3. Right, A is therefore going to be x1 and x3. And I guess for us, it doesn't really matter which one is which. As long as we're just consistent. Right, so I think here then, well, let's just declare some variables. So maybe just A, B, C. Yeah, just the lengths. And if we think, I mean, yeah, possibly these could be real numbers. Right, so, and I guess, well, this is not really A, right, it's actually going to be A squared, B squared, C squared. So yeah, maybe let's write that. Right, so in order to calculate A squared, we said, well, that's going to be, I mean, I think in our example we said, A1 and x1, x3. Although to be honest, I mean, we can just do, x1 and x2. Right, okay, so that's going to be x1 minus x2, and then, so I will actually say if we have it on the A-level syllabus, then this caret is actually used for pointers instead. So what I'm going to do, I'm just going to change this to the IG syllabus. Now, if you want to do exponents on the A-level syllabus, you can just use this double double asterisk, which they also have used in past papers as well. But yeah, let's just do the IG syllabus, right, just so we can use this operator. Right, so that's going to be to the power of 2, and I'm just going to put that in brackets, just so it's kind of obvious. Yeah, just so it's kind of obvious, which operators are happening first. Alright, so yeah, that should be okay, and then I'm just going to copy that and of course do it for, B and C. So let's say, for example, B, that can be maybe x1 and x3. Yeah, of course, likewise, y1, y3. Right, then let's say C, well, that's going to be x2 and x3. And again, y2 and y3. Right, so then how did we check? It said, So I guess, yeah, just based on this, we want to see that if two of them added together are equal to another one. Now, there is a long way you can do it, where you might want to determine, well, which is the longest side. And I mean, this is quite ugly because, well, you need like a long, if condition. You could say, well, if a squared is bigger than, bigger than b squared, and a squared is bigger than, bigger than c squared. And then you'd also want to check, right? So then you want to go and I guess, well, that's going to be, right, b squared plus c squared, is equal to a squared. So of course, this would be one way to do it, although that is going to be quite long. And of course, you then need to go, you then need to check, well, if b is the longest, right, or if c is the longest. Now, there is actually a way you can shorten this, where you can just say, well, if a squared is equal to b squared plus c squared, right, or if b squared is equal to a squared plus c squared, because or c squared is equal to a squared or b squared. Because if we think, like, if for example, let's say if b squared is the biggest, well, if b squared is the biggest, then like a is never going to be equal to b squared plus c squared, because, for example, let's say a squared is 10, but then if b squared is 15, well, of course, no matter what we add here for this, I guess, no matter what c squared is, of course, this is always going to be false, because, well, obviously we're already too big. So I think what we can then effectively say is that, and let me just put this on the other side, just so it's a bit more, similar to how Pythagoras is actually written. So I think we can just check these three different conditions. And then, of course, well, the next one is therefore going to be what, b squared is equal to a squared plus, a squared plus c squared. Alright, then, or that's going to be, c squared is equal to, a squared, right, plus b squared. Right, then, if that is, well, then we just want to return true. Let's go else, and this will just be return false. Then just end if. Alright, let's go end function. Now, to be honest, well, of course, you could use this if statement like this. Technically, you could actually just write like this, where we just go return, and then, well, we just return this thing. Because if we think, this is just going to evaluate to a Boolean, and of course, well, if it's true, right, therefore it's going to return true. If it's false, right, therefore it's going to return false. But I think, in the exam, I guess they do like you to be a little bit more explicit. So I think, just use an if statement, really. Right then, I guess, well, let's think of some values we can use to test this. And I think the easiest way is if we set, maybe we set this kind of first position as being the origin. So, right, this is going to be 0, 0. And then let's say, right, we have x2. So maybe we can say this is going to be 5, 0. And then, let's say this one, so this will just be on the y-axis, but no x position. Right, so there's no x position, or I guess just 0 x position. Let's say, I don't know, 3 for the y position. And this should say true. Okay. If, for example, we make this 1 x position, right, well, of course, now it should say false. Okay, alright, so I think this seems to be working.